Now let's move to the last question. So question 15 is about weak acid and weak base. We'll specify that partially ionized in aqueous solution. Thus, weak acid and base solution contain multiple species in dynamic equilibrium. So what we mean by this statement is what I mean by this statement is in a species, in a system which we have a weak acid or weak base. For example, here we take a weak acid, so HA. So this one we ionize partially, so it will have H plus and A minus. That's why in our solution we'll have the mixture of H plus, HA, H plus, and also A minus in our solution. The question asks two things. First, it's about calculate the pH and the fraction of acetic acid molecule. The protonate in 0.47 molar, where the Ka for acetic acid is 1.79 10 to the 5. And B, what can we conclude from the reaction according to our answer in 15A? And again, what we need to do is, first we need to write our chemical equation. So here I just write the Ha plus H2O. Here is the acetic acid. And then we dissociate into H plus and A minus ion. And in our species we have H plus. In our species we have Ha, where this one is weak acid, H plus and A minus. So at initial concentration is 0.47. And for H plus and A minus we have a 0 here. And for the change of it, so here is depend on our equation. Now we only have 1 mole of hydrogen ion and 1 more A minus ion. So that's why we have this one will be reduced, and then this one will be increased. So we have minus S plus S plus S. So for the equilibrium constant, we have 0.47 minus S and plus S. Next, what we need to do is we know that we need to determine the value of S here. So by using the relation Ka equal to the concentration of product over reactant. So your product is H plus and concentration of the species. So you can write like this. So we just plug in all the value from our equation. 1.7 for Ka is 1.79 for H plus is S, and S over 0.47 minus S. And again we can use this relationship where the S is too small. That's why we use the value of 0.47. And again, when we calculate it, we get S equal to 2.9 10 to the 3 or negative 2.9 10 to the 3, because this one is involved with it is involved with concentration. That's why we can ignore this negative function, negative value here. So we just consider this S equal to 2.9 10 to negative 3. So in order to know the pH of the pH, so pH equal to negative log H plus, so negative log 2.9 10 to the 3. So we get the pH is 2.53. And then this question asks us about the fraction of acetic acid molecule deprotonate, the fraction. So for example, I just give you the example so we can do the rest. So for example, in our equation we have, for example, we take H plus, the fraction, we know that for the fraction of F, the fraction of F equal to H plus over the total species. So we know that this concentration is the concentration everything, or the mode of extension is 0.47. And for the H plus alone is 2.9 10 power of -3 divided by 0.47. That's why we get the species is this one is 6.17 10 power of -3. Here is the fraction of it, and if we convert it into a percentage, it will be, I think it's about 0.6%. So the fraction of H plus is about 0.6%, and the fraction of A minus is 0.6% too. So that's why we call it is a weak acid, because by definition, weak acid and weak base, this species is partially ionized in aqueous solution. So it means, according to our equation, according to our calculation, so for the hydroxide ion, it only ionized is about 0.6%. So we already prove this statement that this weak acid is partially ionized in aqueous solution. And B, what can you conclude from the reaction according to your answer in 15A? So that's why you need to answer, or you need to try to explain the phenomena of this solution. So I will leave it to you, this question, and you can try to do it by yourself, and try to explain it based on my tutorial. I believe you already can answer this question. So that's all from me. I hope that you can get something from my tutorial. I hope you, if you are not answered, please answer it, and I hope that by doing the, or by answering this tutorial, it will give you a more understanding about this topic. You will have a good grasp of this topic. So thank you. Assalamualaikum warahmatullahi wabarakatuh.